Yo guys, how are you all doing? I'm going to do a popular request today. That is to do an A-level paper without a calculator. Obviously, recently I did a GCSE paper with my Hockey calculator. And I did alright, I would say, considering bar the silly mistakes I made. So the next challenge for me is if I can do an A-level paper randomly without using a calculator and see what I can get in it. So I'm going to do a random integer generator. You guys are going to do this with me. You're going to see what I pick. So I've chosen anywhere between 2005 and 2023 because I can't do the 2024 papers. They are locked on the websites. I don't think the 2023 ones are. But anyway, we'll do that. Then we'll choose an exam board together. And then YOLO, innit? All right, so let's see. 2020. Is there even 2020 papers? COVID, right? I don't even think there were papers. All right, let's do a different... Okay, fine. 2019. Okay, so we'll do 2019. And we are going to... I was playing around with this slightly earlier. All right, so we're going to do... Paper 1, paper 2. I guess we might as well take a look now. So we'll do the pure papers. I've been recording hella YouTube videos on Applied, so I'm feeling some what is it, pure. So do paper 1, 2019, and then we have Edexcel, we have Aqua, and we have Okra. All right, let's go. What are we doing? What are we doing? We are doing OCR. So what are we doing? OCR 2019. OCR 2019. Maths. Paper 1 A-level. Is this the question paper? Is it? Yeah. Now, some papers, they lock it. So if I download this as a PDF. Jeez, check man like Dav. Okay. Hopefully I can edit this. So let's upload. I can. Right. I guess then, without further ado... Just get straight to it. Okay, so Bunner formula booklet. Who needs that? Oh no, I can't even, don't even have space to write. I do have a blank document though next to me here. So with this blank document, how can I add pages? Add page. Okay, sweet. So I could just copy this over. Should I do that? This thing's bugging. Do you guys want to see my Microsoft background? Okay. Don't know, that's awkward though. I guess that's good enough, isn't it? Alright, so let's just get straight to it. Solve this inequality. I'm not allowed to calculate, am I? Alright, so we got to use the oi method for factorizing this then. So I'm nervous now. Wait, hold on. Let me use black so you guys can see it better, right? So all right. Where's the question gone? Dude, where's the question gone? Oh my god. Where's... Mate, did it just rub out the question as well? Alright, so when it comes to factorizing, I have 5x and 2x, 2 and 1. Now the 2 can't go in the second bracket, it's going to have to be like this. Now we do oi. So 5x, 4x. That can make plus x, 5 plus 5 minus 4. So that's going to have to be plus and minus. So if I draw my graph, I have 2/5. And I have minus a half. And then it looks like this. I want to know when it's bigger than 0, which is all of those. So bigger than 0 means I need this. X is less than minus a half. And X is greater than 2/5. Right, let's add another page. Okay, now let's go to the question paper. Oh my days, this is... Right, I don't know why it does that, but... Guess the game's the game, man. Make this smaller. So, what's it saying? Point A is such that the magnitude of OA is 8. The magnitude, or the direction of OA is 240 degrees. Show that the point A and the direction of OA is 240 degrees. Show the point A on the axes provided in the answer booklet. What answer booklet? Do you guys see an answer booklet? Yo, where's the answer booklet? Huh? Oh wait, let me find this answer booklet. Did you guys see the answer booklet? What's it called? Where was that? OCR website? Answer booklet. Is it this one? Wait, is that it? Bro, there's no way you just mean... Is that actually it? 5th of June? Is this number 1? Paper 1? Where does it say paper 1? 5th of June 2019. That's the answer booklet. Okay, that's a really strange way of doing things, but I need no answer booklet for that. So they mean a bearing, right? So the point A is such that the magnitude of O to A is size 8 and the direction is 240 degrees, which is here. Alright. Show the point A on the axes provided. Find the position vector of point A. Alright, so this would be 30 degrees. So we have... Huh? Why are you drawing? So we're doing some resolving. That's 8. This is going to be 8 cos 30. 8 sine 30. Cos 30 is root 3 over 2. So sine 30 is a half. So we have 4. And 4 root 3. Now these are both negative, right? Negative, negative. So in terms of I and J, we have minus 4 root 3 I minus 4 JJ. This is part A. Right. Part... Oh, that was part... Oh my god. Davinder said he loves this. This is bugging, man. The point B has position vector 6i, which on my diagram would be over here. Oh my god. B. Find the exact area of triangle OAB. I mean, I'm defacing this whole thing, right? But who cares? Alright, so find the area of this triangle. So this is 6. This is 8, like we said before. Now, this is 30. So we can work out the angle inside, right? Because if that's 30, we can do 270 minus 200. Wait, what am I talking about? We can do 270 minus this 90 degrees minus 30. What's 240 minus 90 again? 240 minus 90. It's so much more stressful. It's 150, isn't it? So it's so much more stressful when you don't have a calculator. So this is 150. We have 6 and 8. Find the area. Half AB sine C. Now 150 is also a half. So we have a half of a half, quarter, a quarter times odd job times 6, 2, so 12 units squared. Part C, where is my black pen? The point C is such that OABC is a parallelogram. Find the position vector of C. O, A, B, C. Okay. So we have O, B, O, A. So this parallelogram. We just need to work out how to go from O to A. Then we'll add that on to B. So O to A, we already know, is minus 4 root 3 and minus 4. So we just need to add that on to B, isn't it? So we're just going to add... am I not in full screen? I'm not in full screen at the moment. There we go. Add that to B, which is 6, 0, isn't it? So that means C is 6 minus 4 root 3. 6 minus 4 root 3i and minus 4j. Okay, seems fine to me. Let's add a page. And let's get the next question. Question 3. And then it's always going to come off. So weird. It's not looking good, Mike. Cheeky functions and that. Okay, that's not what I'm trying to do here. I don't know why it does this. I'm not used to it. I'll get better and better at this, innit? So the function f is defined by f of x is this some completed square thing. Given that f dash x exists, state the least possible value of k. Okay, so the k is to do with the domain. Yeah, so k is to do with the domain. It's talking about half the domain, right? So that's going to be 3, because basically the graph looks like this. Am I here to explain to you guys what's going on? I might as well. So the turning point is at 3 minus 17, because that I'm then thinking aloud, right? So the graph looks something... I don't know if it crosses exactly like that, but anyway. For f minus 1 to exist, we have to chop that halfway, so we can only have x is greater than or equal to 3. So k is 3, basically, right? Evaluate f for 5. F for 5. So we're going to do f of 5 first. 5 minus 3. Skirt minus 17. 2 squared 4 minus 17 is minus 13, right? I've got to be very deliberate with my working here. So we can do f of 13, which is minus 13 minus 3 skirt minus 17, which is 16 squared minus 17. I can do my cheeky trick for squaring. So you square the first number 1, square the second number is 36. Then in the middle, we do 2 times 1 times 6, which is 12 plus 3, 5. 12 plus 3, 1. So then 256. So we're doing 256. That was so random. I'm just like having fun over here, yeah? Let a man live. So you got 4, 16 minus 7 is 9. And then 3, 239. Part 2, solve f of x is x. So for that, I'm going to have to expand the brackets. X squared minus 6x plus 9 minus 17 is x. But I was going to do it at the same time. So we get x squared minus 7x. What's 9 minus 17? Is it like minus 8? It is minus 8, right? 17 minus 9 is 8. So minus 8? It seems reasonable because then this factorizes. So we have 8 and 1. Minus 8 plus 1. It does... Ooh, we have to be careful here. This is how they get you, right? X can only be 8 because x has to be bigger than or equal to 3. Cool. Explain why your solution to C is also a solution to that equation, f of x is f minus 1x? Well, if f of x is f minus 1x, I don't really know how they want me to explain this. Explain why your solution to C is also that solution. Because f of x is x. I guess to do with the reflection line, right? So you have your, if you have a function that looks like, you know, which graph could I show you guys? Even x squared. So you have x squared and then you have root x, right? So they reflect in y equals x. Okay. So where they meet is when the y and x values are the same. But y equals f of x. Okay. Do they want another way of explaining this? So we could explain, okay, so f of x is or f minus 1x is a reflection of f of x in the line y equals x. So they meet, so they both meet when y equals x. Yeah? Good enough. Good enough. Yeah? I'll take it, mate. I'll take it. Alright, so let's do the next one. The next question. Question 4 we're on. Man like Samuel starting a job and that. Now, this is not looking good without a calculator. This is where I'm going to start losing some accuracy marks. I guess I can start saying about. Wait, where is it? All right. What we got? Just let me click off it, man. Jeez. Louise. Right, so Sam starts a... Why is someone frolicking outside? Bruh, chill, man. Sam starts a job with an annual salary of 16,000. It's promised that the salary will go up by the same amount every year. In the second year, Sam is paid to that. Find 10th year. No. So it's going up by the same amount. When you subtract these, you get 1,200. So the common difference is 1,200. The first term is 16,000. U10 is A plus m minus 1 times D. So 9 times 12 is 96. No, it's not. It's 108. 0. 16,000. 26,800. I don't want to lose silly marks like I did in the GCSE paper, man. Find the number of complete years needed for Sam's total salary to first exceed 500k. No, I am cooked. Alright, I am cooked, but it's all good. So this is when SN is greater than 500,000. So we're going to say n over 2. 2a. So when you double that, you get 32,000. Plus m minus 1d. Greater than 500k. Times it by 2, we're talking about a milli. So we get, what is that? 12,000 n minus 12,000. What is 32,000 minus 12,000? 20,000. Then we're going to times it by n. So 20,000 n plus 12,000 n squared greater than 1 milli. We can divide through by all the thousands. We can divide through by 2 for sure. So I get 10n plus 6n squared greater than 5,000. So when is 6x squared, 6n squared plus 10n minus 5,000 greater than 0? Now, you guys are going to have to forgive me because I can't use the quadratic formula here. I'm actually going to have to be cheeky here and not do it like this. As much as you guys would love for me to use the quadratic formula, I really can't. There's just no way. I could divide through by 2 again, right? I could have divided by 4. So dividing by 2, I get 3n squared, 5n, 2500. I can't lie, guys. I'm going to have to trial and error this. N lots of 3n plus 5. How many years? I mean, should we start with 10's probably too small. 20 years? That'll be 20. 20 times, what is that? 3 times 20, 65. 2 times 65 is 130, then add a 0. So too small. 30? That'll be 95. It's probably too big, isn't it? Too big, too small, just right. I can't be bothered. Should I do it? Should I do this as like 1,000 minus 5? Should I do this as 1,000 times 30, and then we're going to subtract 5 times 30? I think that's the clever way of doing this. 30, 1, 2, 3. Then 150. Wait, that's huge. Why is my 20 times 65? 2 times 65 is 130. Wait, why am I bugging here? Oh, it's not 1,000, it's 100 donut. 2,850. I'm close. I'm so close, man. I feel so close to you right now. It's a force field. Should we try 27 then? And then just hope that 3 times 27. What's 3? 3 times 27, 81. 81 plus 5, 86. 42. 56, 60. 12. 16, 17. 2, 2, 13, 2. So it's just under. I'm assuming it's going to be 28. Surely. Surely, man. Surely. Do you really want to miss that mark? Because if I don't use the quadratic formula, I could lose a couple of marks here, man. Do you really want to do it, bro? Was that even 28? Oh, I didn't even try 28, did I? It's time to lock in. Is that even correct? It is. When you plus 5, 89. Such a weird way of doing this. 2, 7, 18. What? What does that say? 8 times 9. That's a 7. 18, 25. 0. 8 times 8, 64. 16 plus 6. 16 plus 6, 22. It wasn't enough. Oh my god. Oh my god. It's actually 29. Final answer. Comment on how realistic this model may be in the long term. Sam starts with a job with an annual salary. He's promised the salary will go up by the same amount every year. In the second year, Sam is paid. I hate these kind of questions. Comment on how realistic in the long term. So it's taken 29 years. I mean, you could say unrealistic. They always want you to say unrealistic, don't they? Comment on how realistic this model is. How realistic could this really be? Your salary most likely wouldn't go up by a fixed amount. It would usually go up by a fixed percentage each year, right? So, most likely, salary would increase by a percentage rather than absolute value. Do you know what? I don't like those kind of questions. So we got question 5. Finally, some real maths. So, okie dokie, okie pokey. Let's add a new page. Right. What we got? We got a curve as this equation. So show that that's the case. Don't mind if I do. Move this slightly. Okay, so we've got, this is implicit differentiation. So 3x squared. I usually like keeping the minus on the outside. It's just something that's pretty annoying. So differentiate the first term would be 6x times the second plus differentiate the second dy dx times the first. Then plus y squared becomes 2y dy dx. 1 just disappears. So we have 3x squared minus 6xy minus 3x squared dy dx plus 2y dy dx is 0. Move these terms to the other side and factorize out dy dx from here. I'd get 2y minus 3x squared is 6xy minus 3x squared. So dy dx is 6xy minus 3x squared, and hopefully this is the answer. 6xy minus 3x squared over 2y. Nice. Find the equation of the normal at 1, 2. Okay, so we have to sub in both 1 and 2. X is 1. So that would just be 6. Y is 2. Minus 3 over 2 times 2 minus 3, isn't it? So you get 12 minus 3, 9. Over 4 minus 3, 1. So 9. So the normal gradient, your perpendicular will be minus 1/9. Y minus the y coordinate is minus 1/9. X minus the x coordinate. Timesing through, we get 9y minus 18 is minus x plus 1. 9y plus x minus 19 is 0. This is my bread and butter, man. That was way easier than the other question. What we got? What we got? Alright, so use differentiation from first principation to show that that's the case. Alright, so let's make a start. So f dash x is the limit as h tends to 0. F of x plus h minus f of x all over h. So we have f of x is 2x cubed plus 3x. F of x plus h is 2x plus h cubed plus 3x plus h. So we have 2x cubed plus 3x squared h plus 3xh squared plus h cubed plus 3x plus 3h. So 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed plus 3x plus 3h. And then, to be honest, that's this part, right? I'm going to minus f of x. So I'm just going to do it here. So I'll write f of x plus h minus f of x because I just can't be bothered to write again. So yeah, we're going to minus 2x cubed and we're going to minus 3x. They cancel. So we get f dash is the limit as h tends to 0 of 6x squared h, 6xh squared, 2h cubed. Is that 3h? 3h, I think. all over h. All the h's essentially cancel. So each term you're just dividing by h. So we get 6x squared, 6xh, 2h squared, and 3. And as h tends to 0, these all go, and we're left with 6x squared plus 3. Nice. Okay, what we got for question 7? Why are you up here, mate? All right. We've got a sequence is defined by this. Use an algebraic method to find the value of n such that the sum to infinity minus the sum to n terms is... it's a sticky one. This is a over 1 minus r. Now, a is u1, which is 25 times 0.6 to the power of 1, which is 0.6, which is 3/5, which is 5 times 3, so 15. And r is the base number 0.6, which I'm going to say 3/5. So my sum to infinity is a over 1 minus 3/5, which is 2/5, which doesn't even give me a nice number, dude. Why wouldn't you give me a nice number? It's 75 over 2. I don't think I've done something wrong here. Surely not. Surely you wouldn't be such a disgrace and to give me such a nasty... Like, 0.6 is 3/5. That's horrible, dude. Okay, so we want to know when 75 over 2 minus a, 1 minus r, to the power of n, all over 1 minus r. Which, to be fair, guys, that is the sum to infinity. So I can rewrite this. So this here is 75 over 2. I could factorize that out and hope for the best. I would get 1 minus 3/5 to the power of n. 10 to the power of 4 is 1, 2, 3, 4. And I guess I could times by 2. And the 75 comes in the denominator. Then we're left with 1 minus 1, which cancels. So we have 3/5 to the power of n. This is my downfall. How could I realistically do this? How could I realistically do this? 2 divided by 75,000. Not too sure. I just don't think I can. I don't even think I can log both sides. Because that's what... Should I do what the mark scheme would want me to do so I at least don't lose too many marks? I think that's the smartest strategy right now. Oh my days, mate. Now log of 3/5 is negative, so the signs are gonna flip. Right now it's damage control. Usually the answer is 19. Just saying, man. Just saying. I think it's 19. Ayo, if that's right, I can't believe it. That would be an absolute W. I wouldn't even be able to explain myself. Alright, how many questions we got? 12? What am I on? Cylindrical tank. Whenever I see cylindrical tank, this is giving me Wagwan formula method. All my students know about a Wagwan method. Okay, can you guys see that? I'm asking you, but we're not really chatting, are we? A cylindrical tank is full of water, where there is a small hole at the base of the tank where water is leaking. The height of the water in the tank is X. Hey, yo, I got colors on here and that. Come on. The rate of change of the height of water may be modeled by the assumption that it's proportional to the root of the height of the water. When t is 0, okay, cool. So they've said the rate of change of the height of the water, it's dx though. Because, no. Oh, okay. Dude, let me just... screw it. You guys can just look at those two dots. Oh, I'll do this. dx, I'll save you guys. The rate of change of the height of the water is proportional k-lots of the root of the height already in there. When t is 100, x is 0.64, and at this instant, the height is decreasing at this rate, so that's negative. So when x is 0.64, dx by dt is negative 0.0032. So you have negative 0.0032 is k root 0.64, which is 0.8. And then 0.8, whoops, 0.8 goes into that minus 0.004 times. Proved. Okay, so that's proved. Find expression for x in terms of t. So this is separation of variables vibes. So that we're going to write as x to the power of a half, which on the other side is x to the power of minus a half. dx is minus 0.004 dt. So we have x to the power of a half. Divided by that is 2. Is minus 0.004 t plus c. Now when x is 0.64, when we root that, remember, we get 0.8 times 2 is minus, when t is 100, 1, 2. So 0.4 plus c. So that is 1.6, so c is 2. So we have 2 root x is, c is 2 minus 0.004 t. Write x in terms of t. So we divide everything by 2 and square everything. 1 minus 0.002 t squared. Hence determine at what time the tank will be empty. So that's when x is 0. So that's just when whatever's in the bracket equals 0. So when this equals... Now I'm going to be cheeky here. I'm going to times both sides by 1, 2, 3. So 1,000. T is 100. Sorry, 500. What is that? Seconds. Wait, that's right, isn't it? 1, 2, 3. 1, 2, 3. Yeah. It makes sense in my eyes. Why am I bugging? Tenths, hundredths, so that's 2 over 1,000. Yeah, okay. Right. This is going to be a bit of a sticky one. Bit of a sticky one. Because my alpha is not going to be exact. But it's fine. I can just take a little bit of an L here. It's not a problem. Let me just scroll up a little bit. So express this in this form where R is positive and alpha. Okay, so nice and simples. R is Pythagoras. I mean, they don't give like what is it? What degree of accuracy they want. So root 58. And then alpha is inverse tan of 7/3. And unfortunately, I can't work that out. Give full details of a sequence of 3 transformations needed to transform y equals cos x to this curve. So if f of x is cos x, what transformations would give us root 58 cos of 3x minus alpha? Well, you are changing f of x to f of 3x minus alpha. Then you're timesing it by root 58. Now here we have to be very careful about the way we describe this. So when it comes to the transformation here, because it's 3x, it's a compression of the graph, right? So we're dividing all the x values by 3. But then shouldn't say we're adding. So say say it was 50 degrees. What shouldn't say is that the 3 squashes it 3 and then it moves 50 to the right. But that's not what happens, because you have, you've compressed the graph by 3. So you actually don't go across by 50, you go across by 50/3. Okay, so we're going to the full details of the 3. So the first one is we are stretching or enlarging parallel to the x-axis by a scale factor 1/3. Then 2, we are translating by the vector. Now we're going right, isn't it? So we're doing nothing on this. And it'll be alpha/3. I'm hoping the mark scheme says that. Alright, they're alpha/3. Then the third thing is the root 58. We're enlarging parallel to the y-axis by a scale factor of r, which in our case we can accurately say is root 58. Part C, determine the greatest value as x varies and give the smallest positive. Okay, well, f max, the largest value, is root 58. Now, when does this occur? You just got to think about the cos graph and when it achieves this maximum. It achieves this maximum when you have cos of 0. So you want what's inside the bracket to equal 0. So when 3x minus alpha is 0, so that is at alpha/3. And in terms of the minimums, that is at minus root 58. And this occurs when the cos graph is at pi. So we have x is pi plus alpha/3. Now, I might lose some accuracy marks here, but the game is the game, bro. Question 10. Oh, no, I'm cooked. Me cooked. But it's all good. I'll live in it. I'll live. Let me scroll up. Yeah. Okay, it's still recording. Just making sure my computer's not bugging out. Okay, so the diagram shows a sector, radius 6, angle theta. The area of the segment, okay, is 7.2. Show that theta is this. So the area of a segment is half r squared, theta minus sine theta, is 7.2. half of 6 squared. So half of 36, just say 18. Is 7.2. And I'm assuming 7.2 divided by 18, 0.4. Because 18 does go into 72 4 times. So yeah, that makes sense. Theta minus sine theta is 0.4. So theta is 0.4 plus sine theta. Let f theta equal 0.4. By considering the value of f dash, where theta is 1.2, explain why using an iterative method based on the equation in part A will converge to the root, assuming 1.2 is sufficiently close to the root. By considering the differential, interesting. So f dash, well, the 0.4 just goes, right? So you just get cos. By considering the value f dash theta, where theta is 1.2, explain why using an iterative method. An iterative method. Are they talking about Newton-Raphson? Because f dash means we're looking at Newton-Raphson, right? Explain why using an iterative method based on the equation in part A will converge to the root, assuming 1.2 is sufficiently close to the root. Now 1.2 is pretty small, but f dash of 1.2... can I just do small angle approximation so I can just see a bit better? So that's 12, that'll be 1.44, 1.44, half of 1.44. Wait, what's half of 172? 0.72? Why is that significant? Why does that mean it will converge to the root? Assuming 1.2 is sufficiently close to the root. Is it because we're just saying that that's not equal to 0? Because with Newton-Raphson, we just can't have the... we just can't have that being 0. We could say by NR... Not really sure what they want from me here. And I'm assuming the small angle approximation anyway. Use the iterative formula with a starting value of 1.2 to find the value of theta correct to 4 significant figures. Yeah, the only time you would use f dash in any iterative method is when doing the Newton-Raphson. So that's what I'm assuming, because you would divide by f dash, right? Okay, I'm just going with it. I'm probably overthinking this. Yeah, unfortunately, I can't do this. No, am I going to be sacrificing 6 whole marks because it's a stupid question? Could I gain a mark from showing what I'm doing? Theta 2 is 0.4 plus sine of 1.2. Could I even go so far and to try and gain a mark from saying that's about 1.2 and saying that's 1.6? Hey, yo, I'm going to try my luck, guys. So 2. It's probably completely wrong, mate, but... yeah, it's going to be completely wrong, right? Because it's just going to keep going up. Screw it. Yeah. Oh well. Use a change of sign method to show that the value of theta found in part C correct to 4SF. Now that's a problem because my answer is not 4SF. Should we just pretend my solution for theta 4 was 1. Let's just pretend I did this so badly that theta 4 was 1.256. So I need to do the upper bound and lower bound. 2565 and 1.2555 because you're treating that as 60. So 6555. Then you're doing f of theta upper bound, f of theta lower bound. I was going to say, wait, should I say that one's positive or negative? I was going to say it like that. So change in sign. And f of x or f of theta continuous for theta being between. I'm just going to say LB and UB. Therefore, theta is correct to 4DP, 4SF. So right now it's a damage limitation on this one, unfortunately. Okay, question 11. That was a weird question. Very weird. Okay. Should make it smaller. Don't mind if I do. The diagram shows part of the curve y equals ln x minus 4. Use integration bypass. So we are integrating ln of x minus 4. Oops, times 1. Okay, Liddy, leave. Integrate, minus, integral, differentiate. Integrate. So you have to integrate this. For that, we're going to have to divide them. 1. So we get x minus 4, put plus 0. So the remainder is 4. X ln x minus 4 minus the integral of 1 plus 4 over x minus 4 dx. So we get x ln x minus 4 minus the integral of 1 is x. And then here we just get 4 ln modulus x minus 4 plus c. So we have x ln x minus 4 minus x minus 4 ln x minus 4. Now in this process, you know, in our integration, x is defined for positive values only. So, you know, as part of this here, they've just put modulus everywhere. So let's just fit the bill. Bill! Okay, it's not really that deep, but anyway, you factorize out that, you get ln of x minus 4. Then we get that minus x plus c. Say the equation of the vertical asymptote ln of x minus 4, so that is just x equals 4. It's when the argument equals 0 there, you can't do ln of 0. Find the total area enclosed by the curve. The lines x is 4.5 and x is 7. Give your answer in that form. Wait. Huh? Wait, am I bugging? X is 4. So it crosses at 5. X is 4. Oh, that is cheeky. Why would you do that, man? Why? Why would you do that? So I have to do between 4.5 and 5 and 5 and 7 separately. Okay, so when I sub in 5 here, 5 minus 4, 1. Ln of 5 minus 1, that's just 0. So I just get minus 5. Minus 4.5 minus 4 is a half. Ln 4.5 minus 4 is a half. Minus 4.5. Did I do that right? 5 minus 4, 1. Ln 1, yeah, 0. So minus 5. And then a half. Ln half. Minus 4, yeah. Here, I'm just going to sub in 7. So I get 7 minus 4, 3. Ln 3 minus 7. Minus 5. Which I already know I get minus 5, right? So you get 3 ln 3. Minus 7 plus 5 is minus 2. Is minus 5 minus half ln half plus 4.5. Which is 4.5 minus 5. So I get minus a half ln half. 4.5 minus 5 is minus a half. Now that's obviously negative, so I need to make it positive. So our area is a half ln of a half plus a half plus 3 ln 3 minus 2. In terms of the form they want, a ln 3, b ln 2. Okay, that's easy. So this is minus a half ln 2 plus 3 ln 3. And a half minus 2 is minus 3 over 2, isn't it? For 4 marks. Okay. What are we on? 12. Final question. Nice. What's the time? I don't know. Whenever I screenshot, can you guys still hear me? I'm not sure. But the time of recording so far is about an hour. So I'll take it without a calculator. Okay, so a curve has equation y is a to the power of 3x squared, where a is greater than 1. Show that dy by dx is this. I mean, when you say show that, I don't really like that it says show that, because I can literally get that answer straight away. You just differentiate the power, that comes down, then you differentiate this. Well, that differentiates to itself, then ln of the base. So when they say show, they should really say by taking logs of both sides. So ln both sides, we get ln y is bring down that 3x squared ln a. Then we differentiate with respect to x. Ln y implicitly becomes 1 over y dy dx. Now this, ln a is just a number, so we just differentiate 3x squared is 6x. Times through by y. They put the 6x, then y, then ln a. So that's 6x. Y is a to the 3x squared. Then we have ln a. Part B. The tangent at the point 1a passes through half 0. Find the value of a. Okay, so we need to find the tangent. So we're going to find dy by dx at uno, which is 6 times a to the power of 3 ln a. So we do y minus the y coordinate, which is 0, equals the gradient x minus the x coordinate of a half. Wait, the tangent at 1... Oh, okay, no, I'm bugging. The tangent at 1a cubed goes through half 0. So we're saying y minus a cubed is 6a cubed ln a x minus 1 goes through this. So that's when y is 0. So when y is 0, x is a half. So when y is 0, x is a half. So we have minus a cubed is 6a cubed. Well, if x is a half minus 1 is minus a half. Minus half times 6. Minus half times 6 minus 3. A cubed ln a. The a cubes cancel, so do the minuses. So we're left with 1 equals 3 ln a. So we have a third. So a is e to the power of a third. By considering the second derivative, show that the curve is convex for all values of x. So convex means it's that V shape. It's to do with the minimums. Minimums means d2. I mean, I should be writing this here. It's when d2y by dx squared for minimums is bigger than 0 for all x. So the second derivative. So I'm going to think of it as 6x ln a. So I'm going to look at it like this. So that's my first term. So I'm going to use the product rule. And here, whoops. Here's my second term. Why is it doubling up on itself? That's really horrible. All right. So, whoa, can we move that? So, differentiate the first term. So 6x ln a becomes 6 ln a times the second term plus differentiate the second term. Now we already know what that goes to. That goes to 6x a to 3x squared ln a multiplied by the first term, which was 6x ln a. I need to show that that is always positive. Now I can do some factorizing. I can take out a to the 3x squared. I can, should we highlight this so we can all see it a bit nicer? So that, yeah, that. We have 6 everywhere. So should we take out a 6? This is really for me so I don't keep making mistakes. So 6. We have ln a. Seems to be it. Because then in the first bracket, we just left with 1 plus x times 6x is 6x squared ln of a. And we already know what a is. So ln of a is ln of e to the third, which is a third. So 6 ln a is 2. So we have 2 times a third, which really isn't relevant here, times 1 plus 2x squared. So you just need to explain that that's always positive, right? So 1/3 to the power of 3x squared. Well, that's always positive, right? So a to the any exponential is always above the x-axis. So we can say 1/3 to the power of 3x squared is strictly bigger than 0. And 1 plus 2x squared, x squared is positive times 2 positive is actually bigger than or equal to 1, which is positive. Therefore, 2 lots of 1/3 3x squared times 1 plus 2x squared is always bigger than 0. Therefore, convex for all x. And that's our answer. That's my solutions. I guess now we just need to go through the answers. Fingers crossed for me. What is this paper again? OCR 5th of June 2019. Answers. We're just going to have to keep flicking. So we have x is less than 1/2 and bigger than 2/5. X is less than 1/2. X is less than what? Oh, minus 1/2, my bad. And x is bigger than 2/5. I was like, nah, there's no way I got the first one wrong. Okay, show A in third quadrant with length x. Okay, that's correct, I'm sure. Part 2, -4 root 3. Huh? Did I write the wrong way around? No way. Oh, wait. How have they drawn it? Third quadrant is here. 240 means 30 there. 8 cos 30. Minus 4. I got that. Why are they getting minus 4i? Am I bugging? Or are they wrong? How is x minus 4? X is 8 cos of 240. Guys, why am I bugging here? Am I bugging? 240. I don't even have my scientific calculator. Wait. Right. 270. 30. 4 root 3. Why am I bugging then? How am I wrong? Ayo guys, I can't lie. I don't think I'm wrong here. It's impossible for me to be wrong. That's literally the I component. I actually think the mark seems wrong. Like fully, I think this is wrong. A is minus 4i minus 4 root 3. 8 cos 240. I don't even know why they're doing 8 cos 240. It is minus 4, you're right, but I actually don't see why that's wrong. I'm putting a question mark on that, I can't lie. Part B is 12 units. They got 12 root 3. Where are they getting 120? Have I just drawn this wrong? That's 30. What did I do? What did I even do here? I did 270 minus 30 minus 90. Dude, guys, I actually think I'm bugging. Like, where have I gone wrong here? Allow plausible angle 150. Must be exact. It's only 2 marks. Could use 60 degrees. No need to... I actually think I've drawn in... They've, like, said I'd put in the wrong place or something. If you guys want to see. Let me zoom out a little bit. Because I actually think they're wrong. I can't lie. I don't see how... Show A in the third quadrant. It goes 1, 2, 3. Length 8. Allow any correct angle. It just doesn't make sense. It just doesn't make any sense. I can't figure out, guys, why that's wrong. They're saying it's 30 degrees here. 240. I can't figure out why that's wrong. That is 270, but they're saying 240 degrees. Or are they saying it's 240 degrees from... Are they saying it's from the x-axis? Guys, this is really poor from them because they've not actually said where that 240 is relative to. Because otherwise it would be up here. Nah, I don't know if there's some specific OCR nonsense, guys. But I just don't see how I'm wrong. I'll take it off. But guys, let me know in the comments. So, I'll subtract 2 answers. I'll subtract 3 marks. Then what's going on here? Do I get follow-throughs at least? Attempt 6i. I got that. 10i plus 4 root 3j. I'm assuming that's going to be wrong then. 10i plus 4 root 3j. Yeah, because they've just got it the other way around. So I've lost 1, 2, 3. 1, 2, 3, 4. Ayo, that's some nonsense. I can't lie. That is so stupid. I feel mad having to take away 4 marks from this. But... Whatever, man. Stupid. Okay, I'm going to zoom out of this now. So what we got? So for 3A, I got 3. It's It's not in domain. That is, again, such a stupid problem. -1. Obtain 8. Okay, at least I got that. So -1. The reflection of the lines. Okay, cool, I said that. So minusing 1 there. Okay, so -1. For a 26,800. Yeah. This was dumb. What? 19. B1 follow through. What's that? Wait, what? Conclude with 19 years. 600n squared. Did I even get that? 600n squared. If I divide that, I don't think I did. Where have I gone wrong? 12,000? 1,200! And I've written 12,000! Oh my god! I wrote that. Did I even get a mark for the last one? Not realistic or unlikely to be realistic. Unlikely salary increase by a certain amount. Pay cap could reach a point where they can't afford. Unlikely the salary by a certain amount. Oh, at least I got that right. So dumb. This one, I swear I must have got it right. X plus 9y is 19. Okay, fine. This is fine. I guess 19. One of the solutions was 19 though. 26. Well, I got 37.5. SN is this. I got this. I got that because when you factorize out the 75 over 2, they divided, so I got that and I did logs. So basically I'm losing 2 marks because I didn't have my calculator. I'll take it. I'll take it. All right, question 8. I proved that. I got that. T is 500. Nice. This was a bit mad, I can't lie. So I'm going to lose my A. I got 2 marks though. So I lose 1 mark. Stretch that. Translation X direction 1.17. Wait. They then did the stretch. Allow informal language for this. Shift, move, squash, translation. What? Yeah, 1/3. Wait. Translation? What? Translation plus 1, they're alpha. Wait. Hold on. So we got stretching the y-axis. We got the third. The translation, they put 1.17. Am I bugging? Because you do the stretch first and then you do the translation. I know my brain's just not working at the moment. Alright, so I lose translation by their alpha. So I lose a mark there. I'll lose 2 marks. So from part A and part B, I lose a mark. I'm going to lose a mark in each of these. 1, 2, 3, 4. 1, 2, 3, 4. I'll take it. It looks like I'm bugging with this whole alpha over 3. Maybe my brain's just not working anymore. It's another stupid question. So I proved 10.8. I got 0.36 and I said less than 1, so the iteration will converge. Why? Why is that a condition? That f dash being... What's that got to do with anything? Must be f dash. Is this something I'm just not familiar with? For an iteration to be convergent? I mean, you're talking about f dash. What's that got to do with the condition on like geometric sequences and being less than 1? I don't know, maybe my brain's just not working or something and I just need to check that one out. So I'm going to minus some mark. I'm too tired to even think about what's going on here. Use iteration. Obviously, I could not do any of that, but let's see if they give me a mark somewhere. Correct first iterate. Okay, well, I didn't get any of those. Well, let's see if I can get something in part D. Attempt relevant values either side of their root. Okay, so I did do that, 1 mark. Must refer to sign change. Okay, cool. So I'm going to give myself the mark there. So I'm going to minus 1, minus 4, minus 4, minus 5. I'll minus 5 there. So minus 5 overall. Hey, okay. Let's see. 3 ln 3. Minus a half ln 2, minus 3 over 2. Cool. Final one. I did prove that. Is that how they wanted me to prove it? Essentially, that's one way I could have done it. What's another way? Yeah, here they go. The differentiation like this. Then e to the power of a third. Cool. Then this one, yeah. So there's my differential. A to the 3x squared. A to the 3x squared 6 ln a. Yeah. 1 plus 6x squared ln a. 1 plus 6x. Yeah, cool. And then it was just yapping after that, right? So ln a is positive. A is bigger than 1. Although, did I say a was a third? Oh, snap. I put a third. Okay. A is actually e to the third, which is, it still doesn't really make a difference to my argument, but consider each sign. It must consider correct working only. Do I be mean here and say like, yo, possibly factorize, allow benefit of the doubt, domains not needed for the M1. I mean, I might, second derivative must be seen, domains must be seen. I mean, should I just be mean to myself, guys? I'm just going to minus 2 just because I said that's a third. It doesn't change the argument. I'll just say minus 2. Right, so what? 2, 7, 11, 13. What's 13 plus 6? 13. I minus 6 marks from here. Why have I minus 6 marks? Wait, why have I minus 6 marks? That's not right, is it? Hold on, so I minus 4 there. I minus 1 there for that domain rubbish. Question 4, I didn't minus 6 marks. What am I doing? How many marks did I actually lose? My brain's not working, guys. I was only supposed to subtract 2. Right, minus 2. Was that a fair subtraction of 2? Yeah, it was, wasn't it? Okay, so let's count again. 4, because I was being mean. That mark scheme, guys, you need to let me know. Why isn't this focused? Okay. You guys need to let me know in the comments about that one. 4, 5, 7. It's loading so slow. 7, 9, 9, 13. 13 plus 5. 13 plus 5. 18. 20. Lost 20 marks? I'll take it. 2, 7, 11, 13, 15, 16, 20. Yeah. What's it out of? Out of 100. So 80 out of 100. So 80%. Was there grey boundaries for here this year? OCR 2019 grey boundaries. A-level. Reformed grey boundaries. So obviously I'm only doing one paper. But, ooh. Wait, where's maths? Okay. Overall, an A-star was 216 out of 300. 216. 72. So I got an A-star, I would say. But yeah. No calculator. So yeah, I guess I'll take it without any revision, I guess. But yeah, guys, let me know what you think about some of those questions. And if you have any more challenges for me, I'm more than happy to have a crack. I'll catch you guys in the next video. Make sure you like the video, subscribe for more maths content. If you're interested in my A-level maths courses, links in the description. And feel free to join the Learn Gang Reddit page if you want to submit your questions for the community to answer. I'll catch you guys in the next one. I'm going to sleep. Nice.